Hi, good afternoon, everybody. We welcome all of you once again, and thanks for attending the session and for the for the time that you waited till now, as we were waiting for a few more attendees to join. So I think it's the right time to start up the session. So today we are doing our second session on the expert webinar series on the topic Go Extra Low Voltage with 24-volt central battery systems for emergency lighting. It's been presented by Mr. David Schul, the technical manager at EML Hungary. EML is one of our principal suppliers for emergency lighting solutions. They are based out of Hungary, and they are experts in manufacturing addressable emergency lighting solutions. And Mr. David Schul is associated with EML Hungary for the last 8 years. He's having vast industry experience in the field of emergency lighting. And he's dealing various departments like commissioning, development, design, support, and responsibility. And he takes care of the responsibility of taking courses and certifications, both internally and externally. And so I hope that Mr. David Schul can give us more insights about the 24-volt central battery systems. And for today's session, we'll brief you more about how to go low voltage with central battery systems. We'll also discuss about the features and advantages of 24-volt central battery systems. And we'll have a live Q&A session with Mr. David so that he can answer to all your queries and questions. Also, before we move on to the presentation, we request all of you to keep a note of all your doubts and queries that you want to ask us, which can be posted towards the end of the presentation from Mr. David. It can be posted in the Q&A box, which you can see down there. Okay. And also you can put that in the chat box as well. So we'll read it out one by one, address it to Mr. David, and he will answer to each of that towards that end of the presentation. So now let's move on to Mr. David. You can start off.
Yeah. Hello, everybody. Welcome to my session. Today, we will talk about the DC 24-volt system, central battery. Our product is from Hungary. I'm working with the EML lighting company, and today I will speak about our addressable 24-volt systems. Okay, let's start it. So the basic information, this 24-volt DC central battery system is a compact system with a built-in charger and 2 or 4 battery inside. The 2 batteries which are connected to each other gives the 24-volt when the AC is missing from the system. This system can be 1 hour backup time and 3 hour backup time. The 1 hour backup time contains 2 batteries inside, and the 3 hour backup time is 4 batteries are installed in the panel box. This is an addressable system. That means the panel can communicate with the lights, and the light can communicate back to the panel with a lot of useful information. All of our addressable system uses only a 2-core cable. That means the power supply and the communication is going on a same 2-core wire. In here, the DC 24-volt system, when the panel is running from AC 230, it gives maximum 32-volt DC for the lights when the AC 230 is on. And when the AC power is disconnected, the panel is still running with battery mode. This voltage can be from DC 28 volt and down to DC 21 volt. Below the DC 21 volt, the panels will disconnect all of the circuits, and the light will turn off automatically to avoid any battery damaging. The panel have 6 circuit output with maximum 20 addressable luminaires per line. So the maximum capacity is 120 pieces of addressable lights per panel. The maximum load of the panel is 18 amp. That means all of the circuits, all of the 6 circuits can give maximum 3 amp per line. The lights can be maintained and non-maintained run. For the maintained light, for example, the exit lights, the maximum continuously power what can the panel gives the light is 10 amp. So 10 amp is a limit for the maintained light, but the full capacity of the panel is 18 amps. This panel can connect it to the network with a simple TCP/IP and the RS-485 network communication. Inside the panel, we use long life batteries. That means if the room temperature where you install the panel, it's around maximum 25 degrees, and you can do a maintenance for every year, and you can carry the batteries. These batteries can run maximum 8 to 10 years. The battery's capacity is 45 ampage. 2 or 4 pieces of can be fit in the box. It depends on the backup time, 1 or 3 hours. The panel is running 24 watt DC on the outputs and the lights, so it's a class 3 safety level, and we use the 2-core cable, how I said before. This system is suitable for smaller and bigger project too. It's a very compact system with 120 addressable units, and all of the light units have a unique ID, which are built inside the light driver. During the installation, no need to use any deep switch to set up the address or any rotary setting for the address, because this ID is built in the driver. It's an 8-digit ID. So when you install the light, just need to write down this unique ID into the drawing. And during the commissioning, the panel will collect these addresses from the lights, and it's very fast. Because it's a DC 24 watt system, the panel can read all of the 120 luminaires by maximum 30 seconds. That means the panel can get and give information for the lights very fast. Maximum 30 seconds can be the reading time for all the 120 luminaires. The next big advantage of the DC 24-watt system against the AC 230 system, the cabling, because in the AC 230 system, we can use only straight line, one by one connected the luminaires. But in here, the DC 24 watts, any type of junction, any type of cabling route are available. So you can reduce the cable length with using junction box, and you can spread the cables multiple way. Because it's a DC 24 watt system, you should use a 2.5 diameter cable, because the lowest voltage, which one is enough for the lights, is 21 watt. So we have calculation help table for the designers to calculate the maximum length of the cable, how much will be the maximum load per line, and it's calculate how many panel you need in one system if you give the quantity of the lights. The panels can be connected to each other to the local area network, which limit is 100 meters per every active device. But the panel have another connection. It's a RS485 ring network, which one is very similar like fire alarm panels. All the panels can connect it to the next two neighbors, and 32 of panel can be connected to the RS485 network. And we can set up one main panel, and the other ones will be the slave panels. That means the main panel is enough to connect to the TCP/IP network to program the other slave panels, because through this RS485 network, all of the programming settings and all of the other commands can be going through from main panel to the slave panel, and in the same way, slave panel can control the other slave panel lights and the main panel lights too. From the main panel screen, we can read all of the slave panels events. And if we connected our laptop with the programming software into the main panel, we can program the other slave panels too. One panel can control by maximum 32 pieces of AC230 control unit. This unit is fit in the general light DB, and it can monitor the general light sub DB AC230 and the general light breakers auxiliary contact normally close information, and it can control the 3 different zones or groups of light in every sub dB. So that means we can make separate maximum 127 groups of light in one system. In one big networked system, we can make separate groups for the light, and any AC control unit can control any light in the system if we connected the panel to each other. Later, I will show how works this AC control units, how works the networking, what means the TCP/IP networking, and what is the RS485 networking. And now I just say the basic information of the panel. All of the panel has 4 pieces of free programmable fault relay. That means in the programming software, we can select different events to control the 4 relays. That means if we want to control the first relay when we have a communication problem with the lights, we can separately program it, one relay to one events, or we can select all of the general events, general fault events, to control one relay. And we can program the main panel to control by the sub slave panels any fault events, and we can use the main panel relays to control by the slave panels. I talk about the different panel cabinets, the battery capacity, 2 pieces of 45 amp batteries or 4 piece, 1 or 3 hour battery time can be ordered. All of the panels contains a 5-inch color touch screen. From this LCD screen is not for programming, it's just for reading information from the panel or from the slave panels. This 5-inch, we can check a lot of information about the charging, the current of the system, the temperature of the box, how many lights we have, what was the last test result. We can check the last 2000 events, and we can check all of the battery information, like the voltage, is it under charging or not, how much is the current of the charging, and how much is the remaining capacity of the batteries. This is a system schematic of the 24-volt DC addressable system. So we can see the panel need a one-phase AC 230 or 240 AC output input. It's one-phase neutral and earth. The battery charger is inside the panel box, which one gives the DC 24-volt for the charging and for the output of the lights. The workstation and the programming laptop can be connected with TCP/IP with the panel. It's just a simple network cable. The panel can connect to each other to RS-485 network and TCP/IP network too. All panels have 4 pieces of fault relays, and the panel have Modbus communication output to communicate with the BMS. The panel have maximum 6 circuit output. We sell only one type of panel, so when you order a panel, that will be with maximum 6 circuit output, not 4 or 2, it's 6 output every time. All of this output with limited with 3.15 amp glass fuse, the positive and the negative cable too. And the limit for this output is 3 amp. All of this output can control maximum 20 addressable luminaires, and the total capacity of the luminaires is 120 pieces. We use the same addressable driver in every type of light. Every emergency light and every exit lights contains the same addressable driver. That means on the circuit we can mix the exit lights and emergency light up to 3 amp with maximum 20 piece address in one circuit. We use a 2-core cable, which one can be 1.5 and 2.5 diameter. But because it's a central battery, you should use a 2.5 cable because the cable length can be longer. I will show what means for 1 amp load and what means for 3 amp load, how long can be the cable length with 1.5 and 2.5 cable. The panel have a two-way communication between the lights. That means the panel can read any address of the system with the LED current of the light. So we can read for one light, how much is the current of the LED, what was the last test result for one light, or we can read all of this information together for all luminaires, because the panel have special maintenance mode. That means we can set up the panel for 30 minutes to full speed communication with the light. That means in every 30 seconds, 1 minute, can be read all of the addresses, all of the test result, all of the communication signal can be read by the panel. And after this 30-minute section, we can print a full report about the communication quality and about all of the information of the lights that contains. It can be reference value of the LEDs, the last test status, and the original ID of the lights, what is the drawing name of the lights, and the communication quality of the lights. So it's very useful during the maintenance. This is a maintenance mode, because when we finishing the commissioning, the system will checking in every hour only once the light status. So every hour the panel is checking one by one all of the luminaires, and if any luminaires have any fault, for example communication fault, the panel store this fault, and if it's going up to 10, so after 10 hours the panels will show automatically the communication error of the light unit. It will give back the original unique ID of the light with the drawing text of the light, and we can read the correct location of any addressable luminaires from the screen, from the programming software and end user software, and the graphic software too. I talk about these junction boxes are available because it's a DC 24 volt. So we can reduce the cable of the circuit, because no need to go in and out in every light. We can use a main cable with junction box, and we can connect it to any way, any light. So it's the communication will going in the same way like when we connected the lights to each other. The panel can controlled by the maximum 32 of CLAC control monitoring device. This device is installed in a General Light SubDB, and this module can activate it by AC230 failure and normally open or normally closed signal. And this module is communicate back to the panel, and the panel will send direct information to the address of any light, which one need to be controlled by the sub-dB failure. So this panel is not turned one circuit or all the circuit together. It's turned, it send the information to the address of the light, and we can make many separate groups of the light, and it can be controlled any other panel, AC control units command. So we can make a very big networked system by the panel, which one can connect it to each other, TCP/IP network and RS-485 network too. So here's the cabling designing information by different load. So one circuit maximum load, it's 3 amp. When we have a 3 amp with 1.5 cable, the maximum cable length will be around 79 meter. If we check the 3 amp with 2.5, this is 131 meter. So this table, it's help you during the designing, but we have a Microsoft Excel calculation table where you can put all of the luminaires on the circuit, and it will calculate the maximum cable length with the maximum 4 watt voltage drop. One exit light current is around 80 milliamp. And here we can see the other emergency lights, 3, 4, and 6 watt types, how much current. So the 6 watt is 265 milliamp. So for example, we can take 20 pieces of exit lights into the one circuit, so it will be a 1.6 amp. Or we can take 12 pieces of 6 watt emergency light in one circuit, and we can mix the exit lights and the emergency light too in one circuit, because all of the exit lights and emergency lights addressable driver inside, it's same. So you can change the drivers inside, but after the commissioning, the addressable drivers in the light need to be stay on the same circuit as before, because the panel will checking the address of the lights. If we need to change any driver or we need to add new lights into the system, we can do it easily with the programming software, but we just have to click on a search new light button, and the panel will search only the new addresses. It needs just a couple seconds, and it will show in a list. We just have to rename the lights. We just have to set to the light group, and that's all. We can add automatically the lights. This is an automatic search, and we can add manually if we know the address of the light. So we can type in the programming software manually the address, but I think everybody should use the automatic searching. Okay. Inside the panel box, we have a main panel which drives the LCD and control the light. And we have a line driver, which one gives the communication signal for the circuit. and we have a battery manager panel, which one have different LED status information. We can read easily from this battery manager what is the current status of the batteries. For example, if the battery is fully charged, so the LED 3 will show the battery voltage information. So if this LED is green, that means the battery voltage, the two battery connected to each other, so the battery voltage is more than 25.6 volt. If the LED 4 show green, the panel is in a normal AC 230 mode. So we can read all of this information from the programming software. We can read it directly from the LCD screen, and we can read if anything happened with the LCD. We can read directly from the battery manager, which is installed under the LCD. It can show temperature errors, battery fail events, battery deep level. It can show the battery charging. It's in a pulse mode or 4 amp charge mode, or the battery is under battery mode, so we don't have AC 230 in the system. So a lot of information can be read from the battery manager too. I talk about the networking of the panel. So here we can see the RS485 network. 32 of panel can be connected to each other in an RS485 network. The distance between the two panels can be maximum 1.2 kilometer. So it's very good if you have different buildings in one site and you have to connect the panels to each other, but the TCP/IP networking cable length is too much, or you can't use the local area network. You can connect it to the panel to each other with RS485 network cable. It's a simple twisted 2-core cable with shielding. It's similar when you use in fire alarm networking. The maximum cable length in this networking is 10 kilometer. No need to use any addressing of the panel because all of the panels have a unique MAC address. And when we click in the main panel with the programming software and click on a search RS485 network panels, all of the connected panels will show automatically with the name of the panel and the MAC address of the panel. So during the installation, just need to write down the MAC address of the panel and the name and just connect it to each other in the Ring network. And all of the information, all of the programming information can be read by the main panel. And we can program any sub-panel, all of the information in one seat with connected only physically with the main panel. For example, we have two separate buildings, and in one building we can use the TCP/IP networking. But the TCP/IP networking rules is maximum 100 meter length cable can be connected from the active devices. So if the building building size is perfect for a TCP/IP network, but you have to connect this building's panel into the another building's panel, you can mix the two type of communication between the panel. So between the buildings, you can use the RS485 networking because the cable length can be 1,200 meters. But inside the building, you can use a TCP/IP network. The advantage of the TCP/IP networking is the number of the panels, because 254 different IP address can be fit in one simple network. So this is the quantity of the connectable panels in one network. All of the panels can be in the same rights. That means all of the panels can control any other panel's lights and back. So when we connect it to the programming laptop, our laptop, into the network switch, we can read very fastly all of the IP addresses of the panel. We can connect simultaneously all of the panels into the programming software, and we can make separate groups, and we can program all of the AC control CupDB monitoring device control the other panels. So the RS-485 network and the TCP/IP network is available for the panels. You can choose between these two types of communication. But I think the TCP/IP network, it's easier. You can connect it more than 32 panels, maximum 254 panels to each other. It's easy to connect it to any panel, your laptop. You can program all panels in the same seat in RS-485 network and TCP/IP network too. Here are some pictures about the LCD of the panel. So it's a 5-inch color touchscreen. It's similar like a Windows 8 design. On the first screen, we will see the status of the system. So we can see the connected devices on a number 2 point. So this system, it's with a maximum quantity of the lights, 120 luminaires. All of the luminaires are calibrated. This calibrating means during the commissioning, the system can measure one by one all of the addressable units LED current. So it sends the calibrating message to the lights. All of the lights will turn on, and the lights will give back how many milliamp is going through the LEDs, and the panel will store one by one into all of the addressing this calibrated milliamp value. After, during the automatic testing or during the manual function test, the system will turn again all of the luminaires in the system, and it will compare the LED current to the reference value. So if in same or maximum 25% less than the reference value, the light will be okay. Or during the testing, the measured milliamp is 0 or more than 25%, the light will have LED error. Or during the testing, it shows communicating error. We have to check the line driver. Maybe something happened with the cabling, or the line driver have some communication damage. So from here, we can read how many devices we have in the system and how many lights are full calibrated. We can check the current status of the power. AC 230 is okay, DC 230, DC 24 volt is okay. How much is the output current? At now it's 1.2 amp, I think the exit lights was in a maintenance mode, and that's why it show output current 1.2 amp. And now the charging current is off because the batteries are fully charged. We can see some temperature of the rectifier and the cooler. On the number 5, we can see the information of the batteries, the batteries voltage, and the remaining capacity of the batteries. The state is okay, and the asymmetric okay, and the fuse is okay. It's information about the batteries current life status. If the charging fuse is blow up, that will show error near the fuse. If the two batteries voltage is different to each other more than 1 volt, the panel will show asymmetric error. On the number 6, we can see an error and alert counter. How many AC230 power failure was after the next, the last restarting? How many DC 24 volt error? How many AC control message came from the sub-dBs? And what is the quantity of all of the alarm events? On the number 7, this button at now is disabled, because if we connected our programming software during the maintenance to the panel, we can enable this button during the maintenance section. If this button is enabled, we can turn on manually all of the lights on, and the panel will turn to battery mode. So we can simulate the full load battery happening. So when the AC230 is missing from the panel and one of sub-dBs give information and all the lights are turned on, we can simulate this event with one simple button. We have an emergency test menu point from the LCD. As I said, during the commissioning, we have to calibrate all of the luminaires. All of the luminaires need to get reference value during this calibrating, and we can set up automatic testing for the system. It can be a short test. This is a function test. When we testing the light's status, it's testing the communication of the light and testing the LED, but it's run from the DC 32 voltage when we have AC, and we can set up a long test that will be a battery capacity test. It can be 30 minutes and up to 3 hours. We can set up this to automatically test for different test period time. And we have an option to start a short function test from the screen. One single click, all of the lights will turn to the emergency mode, and the panel will checking one by one all of the addresses of the system. And after 2 minutes, the system will show what was the emergency test result. From the end user software and the programming software, we can print this emergency test report into the PDF report with all of the useful information of the lights, the test, last test result, the reference value of the light, the name, and the panel information with the date and time and the signature field. The panel can contain the last 2000 events of the system. So in the event section, we can read these events. Different colors mean different events. The blue color show the events came from other TCP IP or other RS-485 networked slave panels in the system. The orange color means something error. It can be any communication error or test faulty error of the system, or in this example, it's a AC control status change. So that means in somewhere in the building, one of the AC control unit detect power failure, and here is the message about it. If we click on the event name, a detailed window will open with more useful information about the event. We can download all of the event list with the end user and programming software. We can print it to PDF, and we can filter it to show just the information what we need. For example, we want to check what was the last 1 year automatic test results. So we can easily filter the event type to EMG test finished event, and the event list, we can see only the test results. We can print it, and we can print directly the last emergency test result into the PDF document. We can give it to our customers with date and time and the signature with all of the information of the system's light. I talk about the light drivers before. All of the light driver are same in the 24-volt system. The emergency light and exit lights use the same type of light driver. We have to connect the red and blue wire into the correct point. So nothing happens if we change the polarity of the cable, but after this device, the line will stop. So nothing damage will happen, but the communication will stop on the wrong polarities device. We can see the unique identifier sticker near the power connection points. It starts with SL, 2 letters, and the next 8 digits will show the address of the light. That one we have to write down during the installation, and this ID will read by the panel. Sorry. And we have a LED connection point in this on this driver. Not only the panel and the programming software can show the error of the lights. All of the emergency light and exit lights have a status LED indicator inside the box. We can see it from outside the light box. It can be a red and green, different combination about the status. So if the light is programmed by the panel, it's found by the panel, and the communication is okay, that will be a steady green. So it's a stored device with normal communication. If we install a new light into the system, that will show the fast green LED, green, red, blinking. So it's a new device. Address is not stored by the panel, so we have to search this new light. If the communication stops between the light and the panel, that will show a blinking red light status. So it's red, 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 red when the light have received error. So something happened with the LED driver or with the line driver of the panel. So we can read any error information by the LCD screen, the last 2000 events and the last test result. We can visually check when we are near the light. We can see the LED indicator, and we can read all of the status information with the end user software or the graphics software. And we can program the fault relays of the panel to send normally closed or normally open contacts to, for example, the BMS or any other system. And we have a Modbus communication directly to the Modbus, to the BMS, sorry. I talk about a lot about the EML AC control sub-dB monitoring module. So this section will be the end of the presentation, and I will close the presentation about with this AC control module. So this module it's connected to each other with RS485 network cable. This network cable can be 1.2 kilometer length, and maximum 32 pieces of this control module can connect it into one panel. But every panel can control by 32 pieces of control modules, and any control module information can send to other panels. So no need to connect it to every floor sub-dB to every panel. Into one panel is enough, because if we use a networking network, one panel can send this information to other panels. This AC230 device is monitoring one phase input or normally closed or normally open signal. One of these modules can control three different light groups. For example, if this module is installed in a second floor and the second floor sub-dB have a power failure, this device will turn on the second floor emergency light, the staircase light, and the ground floor light. For example, these three groups is perfectly to show the exit way from the building. This schematic diagram is show this AC control units options. Firstly, we have to give AC230 for this module. The best way to monitor the general light sub-dB, first we have to monitor the three incoming phase of the dB. First, we have to use a three-phase fault relay. This is the bottom of the picture, this three-phase fault relay. And from this relay output, we have to give one phase and neutral to supply our AC control module. On the top of the pictures, we can see the general light breakers, which are installed in a sub-dB. These breakers have a physical position. It can be on and off. So we have to monitoring this breaker's physical position with auxiliary contact relays, and we can connect it with looping this auxiliary contact to each other, and we can connect this contact into the potential free input. This is the top of the module. It's a voltage free contact. So if the sub-dB have power input failure, any of the 3 phase missing, the 3-phase fault relay will detect it, and it will cut the incoming power input of the AC control device, and the light group will turn on. But sometimes the general light circuits have a short and the breaker will off. That's why we have to monitor the physical position of the breakers. So that's why we use auxiliary contact for the breaker's position, and that's why we connect it into the AC control device, this auxiliary contact. But sometimes we just have to monitor the AC230 part of the module, and sometimes only the normally open, normally closed contact. For example, we have to get signal from the fire alarm panel. So when the general fire alarm signal happen in the building, we can give one AC control device near the fire alarm output device, and just a simple normal close contact for this device, and we can program control all of the luminaires in the building need to be turned on when the fire alarm happen. And in this case, we don't have to monitor the AC230 input of this module. We can disable this function, but every time we have to connect it to the AC230 from somewhere, because the AC control unit have a battery inside and we have to charge. And for the communication, we have to give AC230 for this module. And when the AC power failure happen, this module can send the information back to the main panel with battery mode, because there is a battery inside. If any communication problem happen with the AC control unit, we can set up communication error group settings for this module. So if we cut the communication cable after 1 minute, the programmed groups of the light will turn automatically on when the panel can't find the AC control communication signal. Okay, it's same pictures about the installation. This AC control units, different zones in the floor. Zone 1 with 1 sub dB, zone 2 and zone 3 with different sub dBs, and we have one DC 24 watt panel on the floor. We can make separate groups for the light for zone 1, zone 2, zone 3, but we can see the DC 24 watt communication and power supply cable is going through different zones. Doesn't matter, because we control the light's address, not the circuit, the address. So when the power failure happen in zone 3, the sub dB number 3 will activate the AC control units in a zone 3, and the panel will turn on only the programmed group in a zone 3. Here's another pictures when we have a big office building with 6th floor. We have different panels in the building. For example, it's a self-contained battery panel, but the DC 24 watt panel works in the same way. We can see the sub dBs in every floor. We install the AC control units in every sub dBs. We have 2 panels in the building, and we connected the panels into the network switch. And the power failure happened in 1 floor. This module sends information to the ground floor panel, and the ground floor panel will send network information into all of the networked panel in the building, and this programmed 3 different groups will activate it by 1 sub dB failure. So we can see the staircase lights. It's power up by another panel, but it's connected to the Ethernet network switch, and the information came from the ground floor panel. And the staircase light is activated by a simple AC control unit command. Okay, thank you guys. I finished the presentation about the DC 24-volt system. So I give the voice for Rakesh from Edge. And here will be a question and answer section.
Yes, David, it was a really wonderful presentation. Thanks for the detailed review given on all the specifications and aspects of the system. I hope that it was a value addition to all our attendees. So now let's move on to the question and answer session. So all attendees, that whatever queries that you have regarding the system, you can post it in the question and answer box or in the chat box. I'll read it out for you on behalf of you so that Mr. David can address it and give you the clear replies for that. So if any of you has any queries, you can start posting now itself.
Thank you.
I think, yeah, we have got the first question from Mr. Varun. So the question is like this: during maintenance, if you have to add new lights, is it possible to program or configure the new light without end user or programming software? That means he's asking, is it possible to add or replace a light during the maintenance session? Is it possible to do it directly from the panel, or they have to depend upon the programming software to do that? Means somebody from the agent or the distributor has to come and do that work for them.
Okay, thanks for the question. For programming the system, we need a physically hardware key with the programming software with your laptop. To add any new light or change faulty lights, we have to use the programming software only with a physically hardware key. From the LCD screen, we can check only the last test results. We can check which light have a fault, but we can't program anything from the screen, just checking information. So programming software need to change light and add a new light during the maintenance.
Guys, any other queries or questions that you have, you can please post it now itself, as we have received only one question so far. Yeah, in the chat box, Mr. Aravindan has posted a question here. I am from lighting background, but not strong on central battery systems. I would like to know the current system available. That means the existing system available at the site is 110 volt system. In UAE, 24 volt system is approved or not? Commercially, how it is advantageous for them? So first of all, to answer the first part of it, the system, the 24 volt system is already approved in UAE. Edge Technical Solutions has done the approval from the civil defense. So such support, you can directly approach us. And for the technical part of it, Mr. David will come back, will reply to you now itself.
So now all of our products, what we sell into the UAE and we give to Edge, have a UL certificate. So the voltage can be from 110 volt up to 240 volt for all of the systems. So the answer, yes, the system can be run on 110 watt.
Thank you, David. I hope that makes answer to the question. Now I'll move on to the next question from Mr. Varun. How the central battery system panel is communicating with all the lights in the circuit with only 2-core cable. I understand from the presentation that we have to use only 2-core 2.5 square mm cable for the installation. So you may answer to that, Mr. David.
Yeah, question is good, but answer is secret, I think. So the 2-core cable, it's for the power supply and the communication. It's a very similar like a fire alarm system. If you check the fire alarm, it's only 2-core cable between the devices. It's a ring, but we use a simple straight cable, and the communication is it's a similar like the 24 watt fire alarm system. It's not any special things. It's similar to it, but we have own communication protocol, what we developed up in the last 10 years. So its own protocol. We can't mix with any other 24 watt addressable system. Only the EML addressable lights can be fit on the communication cable, not any other protocol. So we have own protocol for the communication and the power supply. And the 2.5 and 1.5 2-core cable can be perfect for the system. But because it's a central battery system, we suggest for the longer cable distance, the 2.5 cable. But from the catalog and from this presentation, and with the calculating hub program, which one is in the Microsoft Excel, we can calculate the maximum length of the cable, and it depends on the load of the circuit.
Thank you, David. Thank you. Thanks for the answer. Now, I think there is no more questions to be answered.
I think we missed one question from David.
Oh, yes. David has asked a question here. The unit has only 2-core cable and the unit has no battery. So I think his question is basically about on the lights. He's asking like the lights don't have its own battery backup. So I think you want to differentiate about the self-contained lights and the central battery systems.
Yeah, the panel have the 2 or 4 piece of battery, and the light unit have only the light driver, the addressable light driver, and the LED stripe inside only. So no batteries inside the lights. 2 or 4 piece of long life 45 amps batteries are installed in the panel box, and the charger is inside this box. And we use these 2 or 4 batteries to give battery power for the system.
Thank you, David. To Mr. David, actually the one who asked the question, I hope the answer is clear to your question. So now let's move on to the next question from Mr. Abdul Rahman.
Yeah.
He has a point on the maintenance side of it. If you have removed one light, the faulty one in the loop, we need to do the new replacement light installation. That requires program. We can able to modify the panel itself, or we need to do the full program. So what he's asking, when during the maintenance session, okay, so if you have to remove a light from the system or from the loop, do they have to do the full programming in the panel, or is it to modify directly in the panel itself without doing much programming part of it?
Okay, so during the commissioning, or after we finish the maintenance or the commissioning, and we have to replace any lights, we just have to find in a programming software the light name or the original ID, and just a simple right click, delete the unit, just change the line driver or add the new light into the circuit, and we can run automatic searching for the circuits only or for all the circuits together with the one simple commands and search new lights. And the panelists try to search the new unplaced labels in the system. If any new lights found, it's automatically show on the circuit light list, and the searching is stop automatically. But it's very fast, because if we have maximum 120 luminaires in the system, the searching time it's around 30 seconds. So if we add one new light to the system, it's 1 second to find it. And just need to write the name for this new light and set up the group settings, location of the new light. And we have to delete the old one. And we can add this light manually. If we know the ID, we can add it manually into the program, but the automatic searching is more easier than it.
Thank you, David. Now we'll move on to the next question from Mr. Anil Matthew. His question is, what type of batteries are recommended to be used for the backup purpose of the system?
Okay, just 1 sec. I check the type of the batteries. Okay, and I can write it. Just 1 sec. I type here the answer. The batteries brand is PowerSonic, and the type it's PS. So it's a long life batteries.
Yeah, Mr. David, I think
so the PowerSonic brand is it's very perfect for.
Yeah, sorry to interrupt. Actually, I think what the attendee meant is about the specs of the battery. Okay, so I think maybe you would have referred about the brand of it probably and the model number as well. But I think you can just mention about the type of battery, the specs of it.
Yeah, the size of the battery or maximum.
The type of battery. I mean, what type of battery it is? What are the specs required for that?
Yeah, okay. It's a normal sealed rechargeable battery with maximum 45 amp hour capacity can be fit in the system. With it's a 12 volt sealed rechargeable battery. If it's enough information.
Yeah, and I think Anil has one more concern, whether he's asking whether we'll be providing the batteries along with the new systems. Of course, Mr. Anil, we'll be giving it as a complete package with the panel, lights, and the required battery backup that we'll be offering you directly. So now we'll move to the next question from Mr. Varun. Basically, he has got two questions here.
Okay.
I think one we have already read out. So the second one is, in case of AC control module internal battery failure, do we need to change the module or internal battery can be replaced? And how auxiliary control unit is used with AC control module?
That's the first answer. If the AC control have a battery failure, at now the AC control unit have a built-in batteries, but at now we can change the battery just in our factory, but we will change the construction of this AC control unit to change the battery easily by any customers. But the batteries came only from us. But I think any any problem is happen with the AC control module, I think easier to install a new one for the system at now. The second answer, how auxiliary contact unit is used. The module can detect AC230 power failure and the normally open or normally closed potential free input. So we can set up this input for what is the normal status. For example, normally close. If you cut the cable of this input, the module will activate it. So this auxiliary contact near the breaker, it's physically installed, and it's full of the
system,
full of the position of the breaker. So that's one will give normally open or normally closed signal for the AC control module. I hope your question was that.
Yeah, thank you, David, for that clear answer. So due to the limitation of the time, we'll go to the last question of the day. I think Mr. Anil has again asked about the warranty offered for the system. Okay, so Mr. Anil, the warranty that we offer is 12 months. That is the standard warranty that we can provide for the system. So on a project specific cases, you can come back to us and we'll see what is the best possible option here in this case. And so now we'll conclude the question answer session for the day. So any other questions to be answered now, we can come back to you directly to your email IDs with the clear answers. So before we wind up the session, we request all of you to provide all your valuable suggestions and feedbacks to the feedback form that you would be able to see once you end the session here. It'll be popped up on your browser window. We request all of you to fill it up, and it will always help us to improve our quality of the webinar sessions in the upcoming days. So also we request all of you to come back to us for any queries or support directly by calling us or by emailing us, or you can even visit our website for all the products and services that we offer. Also, you can follow us through our social media handles in Facebook, LinkedIn, and Twitter as well. And one more thing we'd like to tell you that about our next webinar session that will be happening very soon, and the session for the topic for the session would be on the revolution of the fire alarm systems by one of our principal manufacturers, Polo and Alpha. So you stay tuned for the updates about the next webinar session. We'll come back to you personally for all the after confirming the schedule of it. And we also request to contact us for any further support that you require regarding this particular systems. So we hope that this session was a value addition to your knowledge base on your emergency lighting and emergency lighting systems. Also, we request all of you to kindly attend the upcoming sessions, and we thank all of you once again for being part of us throughout the session, and have a good day. Meet you soon. Thank you.
Thank you.